So today we have been tasked with a job that will require a wide belt and cross belts for edge rounding. Why does it require a wide belt? We have some of the parts where you see where we have some significant dross, and a cross belt will make this dross round, but it will not remove it. You will still have dross, round dross. On the other hand, we have some aluminum parts which we would not want to run through the wide belt because it would remove too much aluminum and it would create dangerous conditions in the machine with the aluminum powder. But if you run it through the cross belt only, the cross belt will clean up those edges which have a little bit of burr, a little bit of dross, without removing material from the surface. Therefore, very little material removal and safe as long as it gets exhausted into a wet dust collector. We have some thinner materials with a little bit of dross at the corner points and at the entry points, and you will actually see that it has it on both sides of the material. So that this will certainly require a wide belt. This will most likely require a wide belt and not just do the cross belt. Then we have some cuts that are very clean. If you ran that through a cross belt only, they would come out great. And the same with this, but then again in these parts we have some dross, and this is kind of in the middle. You will try it on the wide belts first only and then see what happens. Some of this material is metric, some of it is standard. So what's the machine that we are talking about? We are talking about a machine that has on the first head the wide belt. This is the NS 44-inch wide with a very nice large contact drum, almost 10 inches. A little bit on the softer side, 45 shore, so it presses more on the edges, but it still can grain. And then behind it, we have the cross belts, which give you the well-rounded, smooth, soft edge. And depending on how fast we need to, if you don't want to grain, if you want to grain, you need to run at about 20 feet per minute to have a nice straight grain. And at 20 feet per minute, you will almost get no edge rounding. Plus, you would want to turn these off anyway because they would make a cross grain. If you just want to deburr and then edge round, we need to run between 3 and 5 feet per minute in order to get good edge rounding. And we need to set this very light so that we don't heat up the material too much. And ideally, you actually have a frequency converter on your wide belt unit so that you can slow it down to reduce the heat that you put into the part. So we're going to start with these parts. They have quite a bit of dross. We set our machine to the material thickness, 8 millimeter. We will pick a medium conveyor belt speed of about 3 feet a minute, about 40 inches a minute. And all we have to do at this point is we turn the conveyor belt on. Then we see the conveyor belt speed here. It's actually a lot more. We want to go more like this so that we get good edge rounding. That's actually about 6 feet a minute, but I think that'll be fine. Then we turn the wide belt unit on, and it takes a while for it to get speed. Then we turn the cross belt on, and you see where that position is. It's a 50 millimeter length. We are about 2 millimeters into the material. We actually could come down with those a little bit. And then we run those at full speed, of course. So here we go. So we have 120 grit belt on the on the wide belt, which is probably a little bit too fine for what we want to do. I don't have 100 grit or 80 grit here right now. The part is warm. It is not super hot, which tells me we are good. You see that we have a very nice rounded edge. We have removed all the dross, and what we probably could do is we don't have a lot of radius on this part. We can set the cross belt a little bit heavier. And what we will test that on this side where we don't have a dross, simply by turning the white belt unit off. When I turn the white belt unit off, you will see on the video how the head retracts. So, at this point, I'm going to go in with the white belt another 80,000. And what we will do is we will speed it up until it gets here. And then we slow it down. So now we have a nice edge round on this. So, and I'm going to, so that you can see how we do this, I will mark this. So this was part number 1, right? So it was wide belt, WB, P120. I won't write that after that anymore because it's clear. Plus cross belt at -3. No, this was cross belt, very light, right? At 72 inches per minute. And this was cross belt only, heavy. At 72 inches. So now we're gonna simply repeat this exercise only with the cross belt heavy with the Dross side. Okay. And all we're gonna do is we're going to turn the white belt back on again. Speed is the same. You see we now sit with the machine here with the cross belt at 45, 46. So, here we go. Why do I put the part on like this? Because then it gets an angled action on the cross belt from all sides. And it goes along the features through the white belt, which means it will hold the best. This is a high friction belt that will hold the part by friction. You don't necessarily need the pressure hose, but you can put on the sort of part also through the white belt. Brush underneath this conveyor belt that removes the debris and brushes this, but from time to time you have to clean this. You see we have a little bit of dust on here. If you want to make the parts hold better, then we will do it. So now you see you have it removed and you have a nice and round edge. And we're going to run the back side afterwards. Just the cross belt only. So, moving on, We will run these out later. So this is part number 2, right? This is wide belt plus cross belt, and that is the cross belt heavy at 72 inches per minute. And we probably can make the wide belt a little bit lighter. And the way you can do that is you can either go up with your material thickness, which I wouldn't do. What I would do here is I would adjust it right here, where you see here that we come down a little bit more. No, we need to go up, sorry. And that makes it light. So now we can take another part. For example, this here. This is 8, is the bigger part. Okay? So we have dross around the smaller openings, we have it around the outside contours, and around the small rectangles. See the white line around the part? Very nice edge. Also the inside contours have a white line. So we have full edge rounding. So this was white belt plus cross belt. The white belt a little bit lighter. We have far less temperature in the part. It's very good, right? And the cross belt, so the white belt right now is kind of like medium. And the cross belt is still heavy. And this is a super nice part. I'm sure that you'll be more than pleased with the bird result on this. And again, the other side we would run cross belt only, and we will do that afterwards. So, and the last part in 8mm, I'm staying with the thickness, so I don't have to change the thickness, but I'll show you in a second how to do that. Is this very heavy burr, right? And again, something like this I would run with an 80 grit or 100 grit, not with the 120 grit that I have here. I'm just going to go to the edge of it because I know that my belt is a little bit better, and I'm going to slow down my speed to about 4 feet per minute. That was a part with the heaviest dross. I'm not 100% sure that we cleaned all the holes, but so far it looks good. The outside contour is great. This is clean. This is clean. Everything is clean. This could use a little bit more on this corner. So for that we would have to run it a little bit harder. It's not too warm yet. You would have to run it a little bit harder to do this in one pass. And we'll be able to do this in one pass. And again, with the coarser grit, it wouldn't be a question. So I'm gonna have that last part here. Same amount of dross. And what we're gonna do again is we're gonna come down a little bit harder. Just a little bit. This time we go on the left side. Blowing it down even a little bit more. So now we're at 3 feet a minute. At 3 feet a minute, just so that you can see how we do this. So this part is about 12 inches over the long diagonal. You could put 1, 2, 3, 4 across more or less. So you would run 12 parts per minute or 720 per hour on that side if you fully loaded the belt, which you'll never do. Deduct 20% and that'll give you your capacity. So you're going to run about 550 to 600 part of that per hour on a machine like this. So now we ran a little bit slower, we ran a little bit harder. Now you have everything 100% clean. You have very nice rounded edges because you went slower, right? There's some of the debris in there. The part has more temperature. It's still so that you can touch it. I'm no fac here, so I have sensitivity in my hand. And your edges have a little bit more radius because you went slower. So, and you can see how I know that. I said here, white belt medium, cross belt heavy, 48 inches per minute, and we have a little bit of issues left here. Here we have white belt plus cross belt. That one was still heavy, right? This one was medium. And this was at 36 inches per minute. Those are the factors that are determining the results here. So, now we go to 6 millimeter. We would go to this part. You will say, how long does it take me to change over? Very simple. It doesn't have a lot of dross. So the first thing that I'm going to do is I'm going to raise this again. Then I'm going to set the machine, simple button. This is just a readout. I'm going to set this to 6. There we go, good enough. And we're going to speed it up a little bit more again because we don't have that much dross. Let's do 5 feet a minute, so let me see that. And again, I'm picking an angle where everything runs at an angle. And since this part is the same thickness, I think we can run the same parameters. We have the same amount of dross. I'll just put that in. Nice. I made a mistake with this. This was actually the 1/4" material. It was a 1/4" material, so this ran really heavy, and I heard it, and you can feel it, and it is very warm right now. So this ran way too heavy because I made a mistake with the gauge. So I was off by about 0.4 millimeter, which is 16,000, which on a white belt makes a big difference, right? So I have a lot of temperature in those parts, and we will mark that accordingly. I apologize for that, but when I heard the sound, I figured I better get my calipers out and I'll reset my work. And it is really warm. If you think I'm just touching this and not noticing the heat, you're wrong. It takes me a little bit of focus not to squint my eyes. So, this is wide belt plus cross belt. Very heavy, right? Also here, very heavy. At 5 feet a minute, 60 inches a minute. So, I think that demonstrated how quick you can change over from one material to the next one. So this is actually our 6 millimeter. And like I say, it has very little dross. This has a little bit more dross. So this is what we're going to run next. And again, what I want to do with this is slow it down again. So we don't need to do anything with the material thickness. But I'm going to go down to my 36 inches again. Show you maximum edge rounding on this. So here you see that we have a very super nice round edge. Temperature is much better. You can touch it now, right? This is a great looking part. Your customers will love that. So, check. This part is also 6mm. It has a little bit of dross along here. Okay? But we will turn off the white belt unit at this point, and we will run it cross belt only, because I think it'll clean up cross belt only, just to prove the point. Again, I'm going to speed up the conveyor belt until we get there, and then go down to everything. So overall, of course, we get a little bit less edge rounding because we didn't remove the dross, and the dross was on this side, and the dross is fully removed, it's fully deburred, but it doesn't have the same radius as we have here, which had no dross, that side. So the dross was along here, on that side, but you still see a white line, which means we have a radius, but we have a larger radius here, so this was non-dross. And this is cross belt only, and the cross belt was edge. That's a fully satisfactory part. We're going to run all the parts afterwards from the back side cross belt only, so that you see that too. But that's not so interesting for the video. Now, let's make the switch over to this material, and I believe this was, no, hang on, let's stick with these real quick. So these are all 6, right? Correct? And they have very little dross, so we're going to do those at the same time. Again, it's cross belt only. We're going to run a little bit quicker. You see that I'm running those single file, so that we can get to it. This makes a very clean part just for the cross belt. Fully satisfactory. Same here, inside holes are clean, outside holes are clean. Nothing to complain about. And the last part coming through didn't move. That's a good sign. Same result. So these conditions will be where you don't use. So you're going to say, why do I not want to use a white belt? Well, first of all, the white belt is a more expensive media because it's a glued belt and you remove material evenly from the surface. Abrasive consumption is proportional to material removal. The more material you remove, the more you pay. And the second thing is, you don't want to run your white belt necessarily, at least not at pressure, at very, very low speed. And you get better edge rounding at those low speeds, so it's easier to run that cross belt only. So now we're going to change to this, which I remember correctly was about 3.3. That's right. And we will run both those. And again, this is edge rounding only. So I'm going to put those on, and then I'm going to change my width. my thickness. Why? Because it will take a while for them to get back in. So you just saw a triangle pop up. Because we are about 1/8 underneath the surface, it's telling me that theoretically now with my cross belt, I'm in the conveyor belt. So I can eliminate that by simply going up just a tad with my cross belt. So, another good looking part. See the round edge? You'll be very pleased with that. Surface is clean. It does not take out your scratches, which is a good thing if you have engraving. So on the back side, where we don't have anything, we would not run 36 inches per minute. We would run 48 or 50 or 60 inches per minute. So, same thing with the aluminum. The aluminum, you should only do cross belt because again, we don't want to remove too much material. This is a 3mm thick material, so we can leave the settings exactly as they are here. Maybe 3.2, maybe we just go down a tad. So here we have some interesting conditions because you have this burn that sticks to the inside, and I just broke it off with my finger because it would not remove that because it is sitting on the inside. And it may also not necessarily do this, so I'm going to run this side first. And again, I'm going to speed up the conveyor. Aluminum powder on the conveyor belt if you want to clean up. After a while, it's not making very good. Actually looks very good. We have a little bit here which is just a tad. You may have to cut that by hand. So that is cross belt only. 36 inches per minute. And like I say, aluminum cross belt only. So see this one, you have a little bit more left of this. And I will actually do that, run that a second pass for you. Diagonally to see whether we can remove some more of that, which I don't think necessarily we can. cross belt only, 36 inches per minute, tool path. But what I wanted to demonstrate with that, you still have this issue here because now it's like surface to the machine. It'll glide over that. It'll make it rounder and rounder, but it will not make it go away. So in situations like this, you may have to touch that up by hand before and remove that just with a quick drop of a palm sander. The other side should be fine because everything sticks out. Nothing sticks on the surface or sideways. Okay? And we'll run the back side, that's the non-Dross side, afterwards. So, and again, now we get into the thinner stuff, and that's an interesting lesson too. So this is 100,000 materials. No, sorry, 80,000 materials per millimeter. So with that, what you want to do is you need to bring up the cross belt just a little bit, and then you can come down with your belt. So you see we get triangle again, which means we are going to be in the, and with thinner materials you're going to be slightly in the belt. That's unavoidable. But the parts will clean up nice. You will see that. And the cross belt here is light because we brought it up. But all the edges are good. You will like these parts. Not the heavy rounding, but you will like the part. And I hope that we can demonstrate here is how easy it is to set up the machine and to go from one part to the next once you have a little bit of experience with it. So now we come, and I left it for that. So we went through all this. Now we have these, which are 16 gauge. They're actually a little bit under 16 gauge. They're 1.4 millimeters. So I'm going to come up with the cross belts even more, by about 0.5 millimeter. There we go. And then I'm going to come down with my material thickness, but I do need a turn. On the white belt unit again, because otherwise we will not remove these splashes here. And you do not want to turn your white belt unit on if it was galvanized material, which this is not. But if it was galvanized, you want to work with a cross belt only. And the only thing is I'm going to speed this up because we are using the white belt. So and in the thin material, we're going to heat it up more than in the thicker material. So you need to be more aware of how much heat you put in with your white belt. So, what we are really looking for, did we remove all the little splashes on the inside? We did. These are very small contours, so you're not going to have a lot of edge rounding on those because the cross belt can't really get into this. But all the burrs are totally removed, smooth, and the outside edge is actually great. You will like that. So this was again wide belt plus cross belt at 48 inches a minute. And everything was light. Hardly any temperature in the part. That's very good. So, now we have, see, from the entry point, from the corner points, we have all this little bit. So we're going to run it exactly like this from the other side. And since we know that this is good, because we want to be productive, we're going to add the second one to it, which has less dross. Now we're going to go a little bit to the outside. So the debris you see here is mainly metal, and it is because we don't have a dust collector hooked up to the white belt unit. You see the dust stay on the conveyor belt and it gets brushed aside by the cross belt, to which we also do not have the dust collector hooked up in our demo boat. That situation should get significantly better if you hook up good dust collection, about 1500 CFM per opening, 3000 CFM overall, minimum. You can go bigger, you can go larger and move more air. So this was the back side of the first part that we did, right? Also very nice, you like that. And this is the burr side of the second part. Very nice edge. So, what we're gonna do now, and we're gonna not take a video of that. We are just going to run off all the back sides on the of the part that we did from the front. We're gonna run the rest of this out. This has very little burr. I was going to try that, but it has a big chunk here. So we're going to do all that with the white belt and then return those parts to you. Thank you very much for sending the parts. This was an interesting day.